welcome everyone. Thanks for joining. My name is Shreyas Vaidya, and in today's presentation, we'll be exploring one of the structures role that is available on the 3D Experience platform. And to do so, what we're going to do is we'll set up a simple static structural analysis. Um, and we'll try and explore the 3D Experience platform. So I'm sure you may have heard about the 3D Experience platform, or even use it in your design projects or engineering simulation projects. But I'll try and give you a very high level overview of what the 3D Experience platform is all about, what key values the 3D Experience platform will add to your not just your simulation workflows, but when it comes to collaboration, when it comes to integration with your design teams. We'll take a look at all of that as well. So again, yeah, as I said, this is your meeting. Feel free to ask questions. Feel free to post them in the chat section if you want to, and I'm sure Prasad will help me communicate those. Right, and okay, so a quick introduction about myself. As you all know by now, my name is Shreyas Vaidya. I'm an industry process consultant here at Dassault Systems. I work with the North American simulation team, and I'm currently based out of the central United States. As an IPC, as an industry process consultant, I focus on the simulation roles on the 3D Experience platform. Structures, fluids, optimization is something I focus on and work a lot with these roles. As I mentioned a few minutes ago, I'm originally from Pune, India. I don't know how far it is from Bengaluru, but I just assume 12 hours drive or something. So yeah, here's what we're going to take a look at throughout the presentation. Here's how the agenda for today looks like. So we'll obviously start with a quick overview of different simulation products that the Dassault system has to offer today. We'll then jump on to explore the 3D Experience platform, followed by a quick demo on exploring the 3D Experience platform and one of the simulation rules on the 3D Experience platform by working on a simple static structural analysis. And then finally, I'll conclude with giving you overview of some of the other structural solutions that are available on the 3D Experience platform. So when it comes to simulation products that Dassault System has to offer, and what you see here on the screen is a timeline for over past 20 years, where Dassault System has made some simulation-related acquisitions. Some Abaqus, you may have heard about Abaqus, which is one of the best nonlinear finite element solver out there in the industry. Tosca, the topology optimization standalone product, SIMPAC, the multi-body tool, and some of the recent acquisitions like EXA, which is basically has a suite of computational fluid dynamic tools like PowerFlow, Power Acoustics, PowerTherm, for all your CFD applications. So just wanted to help you understand. So today's I'm sure you have used SolidWorks simulation in your project. So SolidWorks simulation comes into 3 different packages: standard simulation, professional simulation, premium, which is really geared towards different users. So let's say someone like designer or engineer will probably be happy using simulation standard and then professional with all its features. But when it comes to engineers and then in some cases maybe even analysts with its high-end features, SolidWorks simulation premium will help those users in their projects. And now with the Abaqus technology and the 3D Experience platform, what we are trying to do is we're trying to increase the range of the audience that these tools are focused or geared towards, right? And the structural performance engineer and the structure mechanics engineer, which are basically the roles on the platform, or we can just say the products, the structural simulation products on the platform. And I'll get to this, all of this in the further slide to let you understand how the platform is structured. But again, these are more geared towards, with its high-end features, these are geared towards engineers and high-level analysts. And then obviously there are standalone products that we just saw, which again are we have state-of-the-art technology in this product. Some of the really great features that even in some cases only these products have when you compare them with the competition. So yeah, and then the 3D experience platform, right? So I'm sure you guys are aware of the 3D experience platform, and even in general, the company, Dassault Systems, has different brands within the company. So some of the common brands you may have heard about is definitely SolidWorks, CATIA, the design and engineering software. And when it comes to simulation, we have the brand called Simulia, which all the simulation products will fall under. So with the platform, what we're really trying to do is get all the good tools, get all the good features from these different individual brands, and then package it together on one common platform, which is basically the 3D experience platform. And then the way we are structuring these roles, or the way we are structuring these features and then these great technologies in the form of different applications. And these applications will be assigned under different roles. So depending on the type of simulation or type of project you're undertaking, you'll basically will only have to get those specific roles. So and what it does is the 3D experience, the 3D experience platform with all its capabilities, right, coming from all these different brands. Now, specific users in an organization can then focus on some high-end simulations and then focus on their job and then focus on taking it a step further with solving some really challenging problems. Now let's say something like a crash simulation, or even understanding the impact of new and emerging technologies. Let's say something like additive manufacturing. So the analysts, the users, can then shift their focus on solving some really challenging problems using the roles available on the platform. Now, some key values of the 3D experience platform, and let me start with the first one. Obviously, the platform is designed in such a way, it's designed with a very user-centric approach, right? Now, SolidWorks, we all have used SolidWorks. We know how user-friendly it is, and I'm pretty sure once you start using these roles on the platform, you'll feel the same way. And we're obviously going to explore all of it when we shift to the next gear, when we see the structural analysis demo. And look, everything is on the cloud, everything is integrated. Your CAD tools, your CAD applications, your CAE applications are all integrated. And as I just said, you can then focus, shift your focus to solving some really challenging problems like a multi-physics analysis. And what this really does is what all of this does is it helps you collaborate efficiently with all your team members, or even not just within an organization, within your teams, but outside your teams as well. And this increases productivity. You can scale your problems on a level that has that has never. You can scale it to a level which is never seen before, right? So these are all these are some of the key values that the 3D experience platform will bring to your teams. So let's switch to a different gear. Let's go ahead and see the structural analysis demo. I am sure a lot of you are waiting for this. So here's what the scenario looks like. Okay, so we have two different folks working in a team. Okay, both of them want to design or working on designing a bicycle. There's a design engineer who is responsible for design, all the design and engineering work, and the simulation engineer will basically analyze those components. And these two guys, they are connected using the 3D Experience platform. All right, I mean, they have their own hardware, they have their own laptops, they have their own let's say infrastructure, but since they're connected with the 3D Experience platform on the cloud, all their applications, so SolidWorks for the design engineer, which he'll be using to design the bicycle frame, and then the simulation engineer has access to the Simulia roles on the 3D Experience platform, which is what he'll be using to set up a simulation on the bicycle frame, right? And since these guys are on the 3D Experience platform, they also get all the bells and whistles that comes with the 3D Experience platform. So let's say the 3D swim community, where everyone can stay connected. I don't like to say this, but it's like being it's like a social network, right? You have all your team members, you keep them updated with all your work progress, and we'll be seeing all of this, right? And then obviously 3D space, which is something similar to Google Drive, where you can have all your files. And we'll also take a look at how this can be efficiently used. And with all of this, right, the collaboration between the design engineer and the simulation engineer becomes really seamless. So the design engineer came up with a SolidWorks model which looks something like this. Okay, so we have it's a simple bicycle frame. There are 3D and 2D surface bodies in the model. You have the lugs, which connects all the tubes on the bicycle frame, right? And for the simulation engineer, the task is to basically set up the bicycle frame, and you basically set up two different scenarios, right? One for the bump force on the bicycle, and the other one is for a lab test environment where we're just trying to understand torsional stiffness of the bicycle frame. Okay, so depending on how much time we have, we'll see if we can set up both these scenarios. But if not, yeah, we'll obviously go ahead and set up at least one scenario from this. Okay, so from this point onwards, I'm going to step into the shoes of the simulation engineer and try and see if we can set this problem up using the 3D Experience platform. Okay, so just wanted to take a quick pause. Prasad, do you have any questions up until now?
As for now, nothing, nothing.
Okay, no worries. Yeah, feel free to communicate if we have any questions, and then I'll try my best to answer them. Okay.
Yeah,
So I'm now
definitely.
switching to SolidWorks. Let me know, Prasad, if you can still see my screen. I'm in SolidWorks right now. Prasad, can you still see my
Yeah,
screen? Okay,
yeah, I
cool.
can see, I can see.
Okay, all right. Again, so I'm stepping in the shoes of the simulation engineer. The design engineer has already worked on the frame, and now my job is to set up a structural analysis using the 3D Experience platform. So the first thing I'm going to do is I know that the frame was already saved on in SolidWorks and on the 3D Experience platform. So the good thing when you are connected with the 3D Experience platform is you get the option. If you notice closely, you have the 3D Experience symbol. If you click on that, you'll have access to the 3D Experience task pane. Which is basically a connection between your desktop SolidWorks and the platform, right? Now, first thing I'm going to do here is I'm going to search for the file name which the design engineer has already worked on. And once I do that, I'm just going to drag the file into my SolidWorks design area, the graphics user interface, and then um, just going to check here a couple quick things if the correct file was brought in. And now in the 3D Experience task pane, you obviously have the file name and then some details associated with it. And you have the option to set up a directory on cloud, which is basically a collaborative space. I know what collaborative space I'm working in. I have a few options here to convert the file into a format which is more compatible with 3D Experience. It is the .3D XML format. And then what I can do is, since this is already saved, I don't have to go ahead and save it or either convert it. So all I have to do is pick this file, and then these are all the roles that I have been assigned on the 3D Experience platform. And then each role will have all these different applications that I need to set up this simulation. So I'm going to use the mechanical scenario creation. The mechanical scenario creation is creation application is basically what I need to pre-process my model if that is that is something that I have to do. But we're in the interest of time, we're not going to look at all the pre-processing steps, but we will just go ahead and start with just setting up our boundary constraints. So it asked me to give our physics simulation a name, so I'm just going to say SolidWorks user group Bangalore bike, and okay. Let's hit okay, and then I'm going to switch to the 3D Experience platform. Okay, I've just minimized the SolidWorks window, and let's see. Okay. Can you still see my screen, Prasad?
Yeah, I can.
Okay, perfect. So now we are, we are in the 3D Experience platform and in the mechanical scenario creation role. So first things first, right? I have a simulation initialization window in front of me, and I'm just gonna specify the analysis type. In this case, it is going to be a simple static structural analysis. We're not meshing the model yet because we don't have a finite element representation that is already being saved. We'll work on it. So at this point, I'm just going to say okay. And now, if we want to just monitor or just check if everything was brought in correctly, we obviously have the SolidWorks model. So a good thing about getting your SolidWorks model, SolidWorks assembly on the 3D Experience platform is the platform will automatically set up an abstraction shape, which is basically a duplicate of your original body. And now the reason this is important is you don't have to worry about making any changes, making any alterations or your original design, right? So that's something that can be obviously done automatically. And now once you have that once you have that abstraction shape, which is basically the clone of your original body, you can now start setting up the boundary conditions. Before that, we obviously need to mesh the geometry, right? So okay, so what we can do is we can either choose from all these different initialization methods. So I'm just going to choose to create the mesh automatically and then just specify what are the geometries that I wish to mesh on this particular abstraction shape. So in this case, all of the geometries, right? So we don't want to not mesh any component. And let's see how the mesh comes out to be. So I'm just going to say at this point give it a default name, and then I'm going to say mesh these components. And if I do a quick update at this point of time, and then let's zoom in on, okay, so we do have a warning. Yeah, we'll come to this. We'll try and address this at a later stage. So if you see, if you notice clearly, we have meshes on our 3D bodies, but the 2D surface bodies, that those are the tubes of the bicycle. There's still no mesh on those members, right? So uh, the mesh, only the 3D bodies were meshed successfully. So now in this case, what we can do is, and okay, yeah, let me take a quick moment to show you around the user interface of 3D Experience platform. I should have probably done that as soon as we were into 3D Experience platform, but no worries. So on the left-hand side, you have the design tree, which is something similar to what we have in SolidWorks. So everything you work on, all the features that you use on the bicycle frame, it'll get piling up in the design tree. And the action bar at the bottom is where you have all these different tabs: setup, mesh, group, properties, and each tab will have different options, different features, different tools within them, right? So it's a pretty simple user interface. Nothing complicated about this. The design tree and the action bar is something um, we have, or where we communicate with the software, basically. Okay, so the next thing we can do is from the connections, from the mesh tab, using the surface card mesh, let's go ahead and mesh all these remaining tubes on the bicycle frame, right? And uh, we obviously can either mesh them individually, which gives you a lot of other customization options as well. So let's say you can set up a quadratic element, set up linear elements depending on your simulation goals, and then you obviously have the option to specify the mesh size, or the mesh offset, in which case you can also specify any local specifications on all these mesh. So I'm just selecting all these surface bodies, and then in this case we're not going to do any local specification, just in the interest of time. And then what we can do is we can go ahead and just update our mesh. So let's see if we still have that warning message that we got. And I reckon, yeah, we will, because there are a couple of things that we still are missing on, material and section properties. So let's see how we can specify those, right? Just a quick, so I'm gonna turn off the 3D shape right now. And let's assign some nice colors to our mesh so that looks a bit pretty. All right. Okay, so the next thing we can do is assign materials, right? We haven't assigned materials, we haven't assigned section properties. So if I expand this section, the nodes and elements section under the finite element model, I see all the mesh that I have created. And then we also have the surface card mesh that we've manually created, right? And under properties, oops, we do have some exclamation marks for these solid sections, which I reckon is because we haven't specified a material yet. So before doing that, let's specify the section properties first real quick. So if I go to properties, because remember, we have, if I zoom in on these guys, we have a 3D mesh on all the lugs, which were 3D bodies. And then, as I mentioned, right, the tubes were 2D surfaces. So we'll have to specify some thickness. Let's say it's around, let's just assume it's 1.4 millimeters. So what we can do is, we can select all the surfaces that were 2D surface bodies, and we can say 8 mechanical features were selected as supports. We can specify a thickness of, let's say, 1.4 millimeters, and then just hit OK. So now the only thing remaining is to apply materials on all these section properties. So in that case, I can switch to the setup tab, and using the material palette option, I can search from a list of different engineering materials. So in this case, you can either apply aluminum, 6000 series, or steel. Let's just go with aluminum, right? I was working on it and I already have it pulled up, so I'm just gonna use this 6000 series P6 aluminum, which is which I believe is the aviation grade aluminum. So yeah, let's pick that. We have some simulation properties associated with this material here. If you want to view them, if you want to make any changes, that's doable as well. So I'm going to say apply, and look what I have to do to apply the material to all these sections. Just have to select which solid section or cell section I have to apply these or the material on, and then just hit the green check mark. Let's do a quick update and see if we still have that warning message, right? Oops, looks like we don't. So that's a great start we're up to, okay? Yeah, now before we switch to the mechanical scenario creation application to set up the load, set up the boundary conditions, there's one thing that we're still missing. Does anyone in the audience would like to help me out here a bit? Maybe Prasad, what do you think we're missing with the model before we start setting up the or start specifying the boundary conditions? Do you want to take a guess?
We need to fix the fixtures, right, before applying the loads. We need to fix which are static and which are not. I mean, which are fixed points of the structure.
Correct, but we'll also have to let's say specify the connection between these surface bodies and the
Yeah.
3D bodies, right? We'll have to specify a type of connection, because so in most cases, right, it can, if it's a metal, if it's a steel or aluminum, they'll probably weld the 2D bodies with these 3D lugs, right? And then and then in some cases this probably, if it's a composite material, then you can even probably let's say bond it to these lugs. But let's keep it simple, and let's just try to specify a tie connection. So basically we'll tie all the components in this assembly to one another. So you can either do different types of connection, line fastener, point fastener, to simulate your weld connections, right? But yeah, let's just keep it simple. Let's do a tie connection. So for this, I'll turn on the shape, the 3D geometry, and hide the mesh. So look, I mean, there are a lot of surface to surface contacts, right? So we don't want to go and specify each single surface to surface contact or each single tie connection manually, right? It'll just be a lot of work, and then will take a lot of time. So in this case, what we can do is we can do a tie detection, use the tie detection feature, and you'll basically have to specify the tolerance. You'll have to specify the support on which you have to detect these tie. You can also check these boxes where you just mention that, okay, tie the rotational degrees of freedom as well. If you want to you just specify some basic options before you go ahead and find all the surface to surface or connections, or even you get to specify that as well, right? So you get to specify the tolerance, and within that tolerance, all the surface to surface or edge to edge or node to node contacts can be detected. So this is what we have. So we obviously have a lot of tie connections that were detected in this particular geometry. So let's see if we have the abstraction shape turned on as well. So that's basically why we had all the different types. So in this case, I'm just gonna say try and do this again, right? Because we don't want to mesh, or we don't want to tie the original geometry. We're working with the abstraction shape that we already set up, remember? So let's try this one more time. Let's see what we have. Okay, we obviously have 23 connections, and if I say apply, I'll be able to visualize them individually using the connection manager. So if you want to make any changes to these ties, you can access them using the connection manager and go that route. So these are all the ties, and basically now our geometry is tied to one. All the components in the geometry is tied. So it's about time that we start setting up our boundary constraints. So Prasad, as you said, we can start setting up the clamp, or just apply any loads and restraints that the scenario mentioned, right? So just in the interest of time, we'll not set up the first load case, but if I go to the second load case, which is basically clamp the geometry on the rear axle point, and then also clamp the geometry at the pedals, right? And then just twist the frame, apply something like a remote torque or something about the front location of the bicycle frame. So let me switch back to 3D experience. And before that, yeah, there's one step we are still missing, right? We have to set up a procedure. Now we do see a green check mark because we're able to successfully set the structural analysis case. The procedure is something missing. So I'm just going to go with the static perturbation analysis in this case, which will allow me to set up different load cases. We'll just hit OK. And once I have the static perturbation analysis step set up, I can then start defining a load set, right? Now, load set is basically where all the different loads, all the different forces, torques, or restraints will get stored under. And then we can use that load set and assign it directly to the static step. So let's see how we can do that. I'm gonna say apply a remote torque about this surface. That was the wrong one, so probably this one. And about the x-axis, so let's say something like minus 250 Newton meters. And let's also clamp these surfaces, right? So you mentioned about the clamp, Prasad. So let's do the clamp at the point where we have our rear axle. So I'm just gonna pick up the surfaces here. So you can also do a surface propagation, but if you want to pick them. Okay, let me try that again. I selected the whole geometry, which is obviously not accurate. So I'm just gonna pick them and all these surfaces. And this one more surface that we still have to specify here is the surface where the pedals will basically be attached on the bicycle, right? So these are the 13 faces that I wish to clamp, and then we have also applied a torque about the front portion of the bicycle frame. So yeah, that's pretty much it when it comes to the setup. Now, since you're in the 3D Experience platform, you get that option to you get the cloud compute option. So now this is obviously a very simple analysis that you're trying to set up here, but let's say you have a huge problem. Let's say something like simulating explicit dynamic analysis, right? You'll probably need a lot of computational power. So in the platform, what you get is you can take advantage of the cloud compute, and you can go to as far as 144 cores on the cloud. So that's a pretty significant advantage when it comes to the 3D experience platform. So as I said, in the interest of time, we're not going to go and solve this. I know it's a simple static problem, it'll probably be super fast. I already have a model that I was working on. So let's go ahead and take a look at some of the results that are associated with this model. So this was obviously the second step where we did a torsional analysis of the frame. So you can switch between different contour plots. So if I have to visualize, let's see, something like displacement, I can do that. I can just point my mouse on a specific location to get the localized displacement in this case, or if I am on the one Mises stress plot, I can get the localized stress values on those regions. And there's obviously a lot of different options that you can plot different, you can request different contour plots, you can request XY plots of, let's say, something like energy versus time, or anything that you basically are requesting before you simulate the problem is something that you can visualize using these different contour plots and also the XY plots. There are some sectioning options. You can also specify or just play the animation and then visualize, save these animation files, and a lot of other post-processing options. So we'll probably leave it to some other section, but this another cool thing that I would like to show you is, okay, so let's just consider at this point the simulation engineer was able to successfully simulate the bicycle frame. Now comes a point where he has to communicate these results with the design engineer, right? Because this obviously was one of the few first iterations that the design engineer worked on, and based on the simulation results, he would like to, let's say, make some changes to the geometry. So how does a simulation engineer communicate these results? Obviously, we had in current scenario, we can just share screenshots or just generate a report and share it, email it to the design engineer. But as I said, with the 3D experience platform, what you can do is, since you have access to all the other bells and whistles that comes in with the platform, so what I have done is I have set up a group. I have set up a dashboard for, and I'm calling it SolidWorks User Group Bangalore for this project, right? And let's say I create, and this is the browser. This is Google Chrome I'm in, and I'm logged in onto the 3D Experience platform. I'm just going to call it community. And then what we can do is we have access to the 3D Swim community, right? So I'm just going to grab 3D Swim onto the SolidWorks User Group Bangalore dashboard. And then I'm going to say, let's fit it to the screen, switch to SolidWorks User Group. And then I'm going to, let's say, create another tab, which let's just call it Results Review. And in this case, let's search for the physics simulation review application. Just drag and drop it on the tab in this dashboard. Now the physics simulation review application, it's basically a lightweight version of the post processor that we just visualize our results in, right? So let's say you have to share only the results file, only the lightweight version of the complex simulation results file. So you can do that using the physics simulation tool. So let's just quickly take a look at how we can do that. So in this case, I'm just gonna search for the physics simulation object. Remember, we gave a specific name at the beginning of the simulation, so you have to search for the physics simulation object. I'm just gonna, let's say, pin this to a dashboard, and yeah, let's keep them side by side. So all I have to do here is I have to drag the physics simulation object onto the physics result, physics simulation review application, and it'll take some time to load the results, but you'll get access to um, all the experience content that you have generated. So let's say something like, again, similar displacement, all the contour plots from different load cases, so you can visualize them. It again depends on what are some of the key plots that you have requested. So something like a mesh quality plot, or again, switching back to the one mice stress plot. Now, what the simulation engineer can do is, in order to communicate these results to with the design engineer, he can probably even use some tools like, let's say, some markups. He can just comment on this, let's say, high stress area. And once we've done all of this, right, what we can go ahead and also do is, remember I mentioned about having access to the community, and we have already created a community tab, right? So what I can do now is, I can go ahead and publish, let's say, publish this on my team's community. So if I choose to post it as a post, let's say I'm going to do post, and I'm going to switch to the SolidWorks user group Bangalore community that I have already set up. And if I do publish, all the results or the images I'm trying to share it with the design engineers, or let's say there are 10 different members in the team, right? They'll be able to see the post that I just created. So I just switched the community tab, and I have the results. So high stress area, the design engineer can then comment, okay, I'll probably take a look at it. And make those changes and give the file back to you. So yeah, that's pretty cool, right? I mean, you'll be able to in real time share all these results. So yeah, that's pretty much it when it comes to the 3D Experience platform and the structural analyses demo. So let's switch the presentation. I just have a couple more slides, and then we can conclude. So this was obviously the structural mechanics engineer role that we saw, right? And there are a few other roles that are available on the 3D Experience platform: the structure designer, structural engineer, the durability performance engineer, and then the durability mechanics engineer, which basically what we saw today. And depending on what type of simulation you're trying to solve, the complexity of the simulation you're trying to solve, you can choose from these different roles. So if you want to do a simple static analysis or a thermal analysis, a simple thermal analysis, you can use the structure designer, or with the durability and mechanics engineer, you can really solve some advanced high-end simulation. And when it comes to, since we were talking about some high-end capabilities, here are some of the really complex problems that you can solve. So something like a bird strike on the turbine blade of an aeroplane, right? So the bird was modeled using SPH elements, which basically smooth particle hydrodynamics elements. So those are available in the structure mechanics engineer role. The wire crimping problem that you see on the screen, a lot of contacts are involved. So you can use the general contact technology from Abacus, which is available on the platform to solve such problems. Crash analysis, simulate different manufacturing problems, and there's really some, as I said, some advanced features and tools that are coming from all these different simulation standalone tools, and then is now available on the 3D Experience platform. So yeah, that's pretty much it. If you're interested, if you're students or in academia, you can visit the website that I have mentioned here on this slide, or just do a simple Google search, 3D Experience for Education or 3D Experience for Students. I'm sure you'll get a good idea of how to get hold of or just how to access the 3D experience platform.
Thank you so much, Shreyas, for today. The presentation was amazing. It was so knowledgeable, and so we learned so many things about 3D experience. Thanks once again.
Yeah, thanks Prasad, thanks everyone, and yeah, take care. We'll catch you later. Bye.